Hello again, math analyzers. Welcome to your Chapter 8, Lesson 5 notes, all about finding the missing angle measures in a right triangle using trigonometry. Now, this is a place where if you're asked for a missing angle measure and don't know what that maybe second angle is, you can use knowing the lengths of two sides of a right triangle to figure out what that angle measure you're being asked about is. Okay. So, what we need to remind ourselves about is when you have a right triangle, the side across from the right triangle is your hypotenuse. And the angle in question determines where the opposite side is or the adjacent side. So, from the angle in question, the opposite side is all the way across the right triangle, and the adjacent side is right next to the angle in question. Okay, so that's how you know where those belong. And of course, working on memorizing our trig ratios, the sine of the angle measure is equal to the opposite side divided by the hypotenuse side. The cosine of the angle measure is equal to the adjacent side divided by the hypotenuse side. The tangent of the angle measure is equal to the opposite side divided by the adjacent side. So you may be asking yourself, wait a minute, this is supposed to be finding the angle measure. Well, we're going to have a special procedure in our graphing calculator that helps us to plug that ratio into our graphing calculator, and it will spit back out the degree of your missing angle. Now, what you need is to make sure that your graphing calculator is in degree mode. So press mode, make sure degree is highlighted, and then we can continue. So second and mode quits back out to your home screen. Okay, so that's what we'll do. If there is not a diagram, draw and label one. Of course, we're using right triangles, so we know we're drawing right triangles, and then after that, label what you know. So in this diagram, we've got ABC, and ABC has a length for BC of 10 and a length for AB of 16. To the nearest degree, what is the measure of the largest acute angle in the triangle? Well, the other two angles are acute because the right angle is the only one that's not in a right triangle. Okay. But what we'll do is we'll just kind of take a guess as to what one is going to be the larger of the two. And by looking at it, it does look like it's going to be angle B, right? So if not, we'll just use it to figure out the degree measure of angle A. We'll be all right either way. So if I have chosen angle B to be my angle in question, directly across the triangle is the opposite side. And next to that angle is the adjacent side. Now, of course, the hypotenuse side is always the one that's on the opposite side of the right angle, which means that in this particular right triangle, the two sides I know are the adjacent side and the hypotenuse side, which also tells me which trig ratio to use. Cosine of theta is the adjacent side divided by the hypotenuse side. So what I do now is I plug those into the ratio. Theta is the angle measure I don't know. The adjacent side is 10 and the hypotenuse side is 16. So what I do in my graphing calculator so that I can plug this in and find that missing angle measure is I press second and cosine. So second and my trig ratio. Then plug in 10 divided by 16. And when I press enter, it gives me the angle measure. And of course, I was told to round to the nearest degree. So here, theta is approximately 51 degrees. Now, let's just think logically real quick. Is this going to be the largest of the two acute angles? Yes. And the reason is because if this were an isosceles right triangle, the other two angles would be 45. So that means that one angle is going to be greater than 45 and the other is going to be less than 45. And the greater of those two angles will be the largest acute angle in this right triangle. Okay? Think about it this way. if you were using A, it would be opposite over hypotenuse, and that's sine. So second and sine of 10 divided by 16 is 39 degrees. So which is bigger? The 51 degrees. Okay. I just did the problem the opposite way too, just in case, just to show you I could get that. All right. If a right angle is formed where the center pole meets the ground, okay, this must be in a tent. What is the measure of angle A to the nearest degree? Oh, fine. From measure A, from the angle A, and this is our right angle, that means 12 over here is the hypotenuse, 8 across from it is the opposite side, and that means this is the adjacent side. Not that I care, because there's nothing to do with an angle measure or anything, or a side length in A or in the adjacent side. So opposite over hypotenuse, so that's sine. So sine of A, that's the angle measure, right, is opposite over hypotenuse, which we can plug right in as 8 over 12. And that means the measure of angle A is going to be approximately, let's see, second and sine, 8 divided by 12, and parenthesis, round to the nearest degree, 42 degrees. There we go. Make sure your graphing calculator is in degree mode. Press mode. Make sure degree mode is highlighted, right? So make sure your graphing calculator is in degree mode. And this time we're going to know our two sides. We need to press second and the trig function. So it'll say the little -1, like it's the inverse function, because it is. And then you enter your ratio. Okay, so going backwards using that to find that missing angle measure. So that's what you want to be on the lookout for. Okay. Guys, good luck. Have fun. This has been Chapter 8, Lesson 5, all about finding those missing angle measures. So have a blast and let me know if you need any help. All right. See you soon, Math Analyzers. Bye.